So with that, I would like to invite our second speaker for the session, Mr. Mohan Jindal. Mr. Jindal is the founder and CEO of Chipspirit. May I please request Mr. Mohan Jindal to join me on the stage?
Hello, Vikas.
Welcome, Mr. Jindal. You can please start sharing your screen, sir.
Okay, thank you.
Okay, perfect. Stage is yours, sir.
Yeah, thank you. Thank you, Vikas. Thank you, DSCI and team for having me here. So first of all, I'd like to introduce Chipspirit. So we are working on multiple things. Every chip has a spirit, that is our thing. So every chip that you use, not the potato chip also. Potato chip also might of course have some spirit, but I'm talking about the VLSI chips. So that work on the laptops and mobiles that you're using right now, and we are talking through so many wired networks and offline online devices. So we are Chipspirit. So I'll just take you through what is hardware software in a brief moment. So in terms of this was one of the story on Bloomberg. This small chip, which is like, I mean, it is very tiny. Okay, you can see this is a normal finger, and it's this much, but it created a big hack. So this small chip was into every America's company, every server which was being used at all a lot of defense places, and this was inserted when the motherboards were manufactured. So this is something that you can see. Okay, and you know the intention. I mean, intention was to maybe mirror the data to some places of uh, uh, adversary where they really want to, do what they do after, let's say, mirroring and reusing the data in their own manner. So, and there is like, of course, you have heard about Silicon Valley, right? So in terms of, so what is Silicon Valley? In the US for sure, I mean, as a physical location. But in terms of silicon, right? So this changed the game a lot. In terms of earlier algorithms were not even doable. So in 1970s or 80s, when we miniaturized a lot of things and everything shrank by, let's say, 180 nanometer, and then 90, and then 60, then 40. So all those things were possible. So that's when Silicon Valley came into picture, and these tiny chips are actually everywhere, changing a lot of things in terms of how we see technology and how we use technology, how we talk to each other. Like this video conference also is enabled by a lot of these chips in between. So at Chipspirit, what we do is, this is our team briefly. So this is me, Mohan Jindal. I have about 20 years of experience working with an excellent team at Chipspirit. And we had an outing before the COVID actually, so we are waiting for COVID to be over for our next outing. So we are about 40 plus members, and a lot of parties are due actually, I know. And this is Sriram. He is about 25 years of experience, and Ravi is about 20 years of experience. So we are working together to make some of these things happen on the chips. So opportunity in terms of security, I mean, we are using all these hardware chips and everywhere in our, especially it is very critical in the defense establishments or finances, or I mean, like this conference we are having, it may be a public conference and people can join in, but there are a lot of such conferences which are in parallel happening as of now, which are of course confidential for different reasons. So, and these chips contain a lot of backdoors, trojans, loopholes, intentional loopholes also. Like that, the chip you saw, that was, you can see on the fingertip, right? But there are a lot of circuits inside that chip which you can't even see, which you need to peel off some of the metal layers on that die and then get into package and all that to see some of those things. And you may not be, I mean, it needs a lot of engineering to actually go and find out if there is Trojan or backdoor, intentional or unintentional, in that to mirror something which the adversary might be interested in. So that is the opportunity we work on. Our current solution, Abhed One, it's a big box right now that you see here. It consists of 4 boards as of today, but we are targeting a single board with very miniaturized solution, and we may go for the SIC solution as well, where it will be a small chip, just the which can sit on the thumbnail later on, depending on the market. And the uniqueness of our solution is it like first time in the world. It contains no core, no software, no firmware. It is complete data path is implemented in the circuit only. Okay. So we will take questions, I mean, towards, or you can ping me in between also. Okay. So Mr. Vikas, please help me if there is something from the audience here. Yeah, thank you. And in terms of our current prototype that we have, so let me explain a little bit here. So it goes into a plain text stream is coming in, and there's an encryption server inside the Abhed One. PS is the programmable subsystem. PL is the the programmable logic, which contains the, at present we have implemented 256-bit AES on this silicon, that we are using right now. It's a FPGA device. So there it will do the AES encryption and decryption, and then the decryption server will give out the plain text stream. So we have proven this prototype solution in our labs. Okay, there are multiple other versions also that are being proven right now as we talk. The first use case is like for the Navy specifically. We are working with Indian Navy for past 2 years now with their excellent commanders and lieutenant commanders. So they need is like on one ship they will carry a USB. With this Abhed device will be there, and with that key they will encrypt some plain text into a ciphertext USB stick, and that USB stick through helicopters is sent to the other ship or on the shore or in the headquarters or in the submarines, wherever, and then it will be plugged into a similar Abhed system with the same pre-shared key, and you will get a plain text out. So this is the main functioning of Abhed One device. So here the main thing is the whole data path, the control path, the finding out the this particular files which are to be encrypted, decrypted. So that is programmed through some stuff here, which is like a user interface, and then there is a keyboard and there is a display through which you get the authentication and a lot of other stuff configured to do this step. Okay, and the key is pre-shared, which can be stored for 6 months to 1 year inside this, and can be of course reprogrammed, and all those things are there. So there's a lot of flexibility in this device, and the main thing is there is no software, no firmware used, no core used to do all these transactions for USB to USB. This is the offline use case right now. Okay, Mr. Vikas, everything is up, right? Can you hear me? Just maybe quick sound check. Okay, I don't know.
We can hear you perfectly. Once you're done presenting, we can proceed to the Q&A now.
Sure. Thank you, Mr. Vikas. Okay. So, and this is the use case number 2, where we have a bump in the wire model, where let's say you are sitting in your home right now, home or office, and you are A and I'm sitting B in Bangalore. So we'll have a bump in the wire, which will be like Ethernet 1 gig interface over here, which is a plain text interface. And this is Ethernet 1 gig, which will be a ciphertext, which will go through a public network, and on the receiver, it will be received as 1 gig. And then you get a plain text data into the receiver end. So this whole transaction is completely encrypted using the hardware-based encryption, which is completely built-in hardware. So there's a tunnel which is established before all this network is established, and before all the good data is transferred here. So there's a lot of engineering that happens before actually all this is done. So this in some scenarios for especially defense and node-to-node servers, this is very much applicable, and for IoT devices specifically, where you have node-to-node servers accessing the very critical data, this is very, very useful. And there are a lot of applications we are working towards with different industries also. And the other use case is, let's say like this, where you switch in the plain text USB stick on the source, and then it is we create the packet, we packetize the data, we establish the tunnel through hardware circuits, and then we transfer it over the public network to the receiver end, where again of course there is a tunnel and all that established before this happens, and at the receiver end we decrypt and send the data into plain text USB stick at the headquarters. So this can be like there can be a nodal office in an island where this type of system is set up, and in Delhi headquarters they can receive the data. So this is especially useful for the defense applications. And there are a lot of other interesting stuff in this product that we're developing. Of course, Ethernet to Ethernet and USB to USB you have seen, and USB to Ethernet and the Ethernet to USB also you have seen. So those are the basic use cases. And we are in discussions to enhance this 1 gig to 10 gig also for next generation server requirements. But yeah, first we have to get this Abhed one completed. And it contains a lot of user authentications, I mean 2 layers. In discussions with defense team, tamper detect, if someone is tampering with the system, it will detect and it'll erase all the data. It will kind of destroy the whole system, the algorithms inside the motherboard on a detected event. And it's complete hardware, all things are working in parallel. So the good thing here is like you can get as close to the line rate as possible. There is no software to actually execute in a sequential instruction based manner. So this is complete hardware implementation. And internal memory, of course, there are encrypted keys, and TRNG for data obfuscation is used. Of course, user mode and maintenance mode for someone to maybe reconfigure some of the security stuff on this device. And of course, we have a couple of other companies. We are working on 5 nanometer, 7 nanometer, 10 nanometer executions with different customers of ours. That is about Chipspirit. And we, of course, have a couple of turnkey solutions in terms of SoC design, verification, and physical design. So a lot of stuff is there. You can go on our website and check out. This is about the contact things. Recent awards that we have won, one of them being the IDEX Disc 1. That is Innovations for Defense Excellence, Defense India Startup Challenge 1 in 2019. And we were also winners in the idea stage at Cybersecurity Grand Challenge last year. And right now we are developing the Abhed 1 product with the Indian Defense, Indian Navy. And we spoke to Mr. Bipin Rawat. He is very interested in the product, and he visited our stall at Aero Show, and he is interested in taking it to the Silicon also. So we are in discussions on those stuff as well. And our Defense Secretary, Mr. Ajay Kumar, CDS Bipin Rawat sir, and Mr. Rakesh from the Ministry of Defense for the procurement. They visited our stall. Our Mr. Rana Singh ji, our Defense Secretary. So this is a couple of our, kind of recognitions that we have gone through. So any questions? I'm open to questions. Please, on the chat or somewhere we can enable that. Or I can go in details. There are a lot of things to discuss for sure. So, Vikas, should we open for questions? Is there something on chat that you want to?
Yes, Mr. Jindal, you can please stop sharing the presentation.
Okay.
We'll be able to see the presentations.
Thank you, Vikas.
Yeah. So I don't see any significant questions. But if you would like to elaborate on certain topics that you presented, that we can use the time.
Yeah, sure. So in terms of security, of course, the main idea is to give the data to the intended destinations. That is the most important aspect of what you want to do with your data, right? And data is very, very important in terms of course, finance and defense transactions. And everybody may not need such a device to actually, kind of use their data transactions. So It is based on, of course, everywhere you have different type of levels of security, right? So this device will be specifically required where we have a very high security, high, uh, secure interactions in terms of, let's say, where is our Rafale aircrafts being kept, or how, what is the movement of defense, or interactions between defense secretary and defense ministers, or defense interactions, and also in embassies. So between different embassies, so there are a couple of these devices which are useful, and some of these things are already being used in by so we now we are getting into this. So we know that Russia has their own devices where they are hardware based enabled devices which they are using, and US also has their own such hardware based boxes which they develop on their own, and they use it for their own requirements and suggestions. So there are a lot of defense based uh, places where this is useful. And also in finance transactions, you don't want your finance data to be misused by somebody, right? So same is the case from banks to banks transactions, where they place their servers. And there is a next market that we are looking at, which is HSM, hardware security modules. So that is an established market for sure, and but there are a lot of new opportunities there we are working towards. And in addition to that, we are talking to CDAC, that is CDAC India, where they have a couple of things in terms of course, server to server communications, and they are the backbone in terms of all the networks, government specific networks which are being used and developed across India. So these are a couple of stuff that on the markets that we're looking at. And a lot of interesting stuff is done by our Chipspirit team. I mean, we are yeah. I would love to have questions and interactive session as well, because I can talk for days, okay, like this. So I can talk about silicon, talk about all these security things, and let me see if there is any Q&A.
So we do have a question from
Okay.
Amit Jha.
Mm-hmm.
What about data load? How does it impact throughput in high data environment?
Excellent. So the question is, what could be the reason why companies still continue to invest? Okay, that is a different thing. Sorry. Data load and how does it impact throughput in the high data environment? So as we see here, it is 1 gig Ethernet. Okay. So in terms of data load, you mean, of course, let's say if it is USB, right? So in our transaction are USB to Ethernet, or Ethernet to Ethernet. So 1 gig Ethernet is what we consume, and there will be some overhead, agree, on the ciphertext side, right? So there will be some impact, but very, very minimal compared to a software transaction. Okay, where they need a couple of more layers uh, to actually uh, make the data on the ciphertext little bit loaded more than the plain text data. So we also have such loading, such headers to preserve our uh, some of the key requirements that we need at the receiver end to I will say, decrypt the data that we have encrypted. So there is some load, but it's very, very minimal. I don't have the exact numbers, Amit, but yeah, you can in terms of performance. I see another question from you. It's excellent in terms of performance as compared to any of the software encryption technique that you may use, because software techniques work in a sequential manner. They have threads, I agree, they are multi cores, multi threads, but here if you see, we have a separate engine for everything. So there is a separate engine for encryption, which is in hardware, a separate engine for getting in the data, which is also in hardware. So it is kind of parallelly, everything is working and pipelined also, so that at in a single cycle, everything this everything is getting executed, compared to a software. Of course, software uses a lot of these parallelism and different functional floating point, other units to make things parallel, but still it's a general purpose, or not exactly general purpose, specific purpose processor also, which will go through certain instructions to execute. So it is very good in performance compared to any of the software execution, which will be, of course, in sequential order, maybe let's say 3 thread also, 4 thread also in parallel with some dependencies. Here, all those dependencies are very, very fixed. Yeah, and our clock speeds are like, of course, 500 megahertz right now on the FPGA that we are using. I mean, 250 is our current target that we are implementing, but we can scale very, very quickly based on the data requirements and throughput requirements. That's why we are targeting 10 gig in our next devices.
Okay.
On the Ethernet
So
side, yeah.
I think that answers most of the questions, and
Yeah.
we are right on about time as well. Thank you so much, Mr. Jindal, for joining us today and sharing your remarks.
Thanks,
And
Ron, Mr. Vikas.
thank you, everyone. I would request everyone to please head on
Yeah.
to the main auditorium for further interesting sessions.
Thank you.
Thank you so much.